Good morning, everybody. Thanks for coming. My name is Itay, and this is Simon.
Good morning.
We're working on a game called Mushroom 11 that's still not out, but we are presenting it next week in PAX and showing it off in the last few months. And we want to share a little bit about on how we designed and what inspired us with the art of the game. But first, I want to quickly show you a video of where we are right now. So here's the video. So, yeah, second. Of course. That's interesting. All right, so I will start the presentation again. All goes well. All right, so quick explanation about this game. It started as a Global Game Jam 2012 project between me and my wife, Julia. The idea was pretty quick that we were trying to make a game that is all about using destruction as the only mean of motion and control. So this is how the games looked after 2 days, and we decided that we are definitely going to try to take this to what we really thought the game needed to be.
All right, so we have the proof of concept, but what we're starting with here is more or less a blank canvas. I mean, it's black and white, no color, and we really want to fill out this world so we can describe a place where this entity can live and also have an opportunity to tell a story. So we thought our world would be a place where many people once lived, but they're not there anymore, and something terrible has happened. And we get to wander around this place now. So we looked online for imagery that kind of gave us the vibe we were looking for. And I do not take credit for any of this wonderful artwork you're about to see, but they were very inspirational and helped guide us. This one artist, Tokyo Genso, that you might have heard of, he does beautiful renderings of Tokyo, kind of in a post-apocalyptic kind of phase. And it's really nice the way he depicts the structure of their lives. Slowly being overtaken by moss and things like that, and we aspired to achieve this kind of feel in our game. And looking at this imagery, you might be prompted to think about the people that live there, but mainly what happened here. Why is everyone gone? And we wanted that kind of mystery in our game. So we thought about movies we liked that depicted civilizations that have deteriorated, like WALL-E and Planet of the Apes. And what about the people that lived there? What kind of society did they have? Were they happy? Were they living in some kind of oppressive dystopia? Did their way of life contribute to their downfall? We thought about things like this. What kind of industry did they have? Was it like clean and modern, like we're always pushing for, or was it heavy, raw kind of industry? Working on this game, you're kind of living with it in your head. So when you're walking around, you see things like the pavement being overtaken by plants, or going to your rooftop and seeing, the end of the world coming. It kind of fills in the blanks in your own mind while you're working on the game to mesh with what you're working on. So it's very important just to see these cues that are around you. And of course, going out into nature, you find so many weird things. You can search the internet, and it's all stranger than any bizarre science fiction movie, the things that nature has already created. So that's also a great source of inspiration. And also games that we like that are similar to ours in layout, like kind of a 2D playing field, but that we want to show a lot of depth and have a lot of mood. We looked at games like Rayman Origins and Limbo, one of our favorites, and studied them and drew as much inspiration as we could from these as well. So those are sort of the things we're thinking about as we're going about designing this world. And we basically just start sketching. These are some of the first drawings I did. And vehicles, how does a city look like after this terrible thing, which we can't say anything about, has happened? What do the structures look like? Are they littered with street art? Do they get around on escalators? What are the houses like? Are they concrete? Of course, there's the mundane, telephone booths, which are a little bit retro as well. Signposts, parking meters, things that fill up our lives on a day-to-day basis that we don't really think about, but they're really important to have in your world if you want it to have some kind of connection to the player. And of course, the really fun stuff is the bizarre things that you'll come up with. Creatures and whatnot, and we knew we wanted to have a lot of those in our game. Okay, so we first started in this direction, kind of a very lush, Garden of Eden after, man has left, and it's taken back, what it once had, and it's beautiful. But we decided that this was too lush, too happy, too much of a pleasant way for mankind to go out, for everything to be great after we're gone. So we thought maybe we need to, kind of go more towards the pessimistic, the gray, the darker colors. This might have been a little too dark, but it was the next step in our evolution here. And, continuing on, we knew, but the darker hue was very important because, we wanted to show some color in the different creatures that inhabited this world. So, continuing on, and we end up here, which is what our game looks like now. And we brought in a bit more color, but a lot of detail. And trying to manage the color and contrast so that the things that really matter when you're playing, like our mushroom here. This is a checkpoint. And things that you might want to interact with, they stand out. So that was our process and how we arrived where we are now in the game.
All right, so going back to the original design of the game, we started thinking about how we wanted the mushroom, this organism, to look like. So we kind of started figuring out what the mechanics are, and they were pretty clear from the get-go. What we see there is there's a constant amount of mass or number of units that this cellular organism is comprised of. And the only thing you can do is delete cells. As you delete those cells, in order to fill up those lost cells, you'll have to regrow, so you would end up in the same amount of mass. But this brings also splitting and reattachment and everything that can arise from that. And all the different pieces would live individually and have their own forces that applied on them. But there are no force that is applied externally from the mushroom. The mushroom is, well, the metaphor is a moss or like a fungus, which is, it grows into crevices and tunnels, but it cannot push onto anything. That's a design decision mostly, but also feels proper with respect to how the game plays. Also, one thing that was very important in terms of gameplay was to have a rigid skeleton. So this thing holds the weight of anything that is that lays on top of it, and it has no gooiness. That also has a lot of effect when it comes to creating challenges and puzzles. So once you figure out exactly what the mechanics is, you can start sketching out ideas on how you want the mushroom to look like. So you can see that these are sketches that Simon did on the first day we met and started discussing how the game is going to look like. And we try to go into many different approaches. We obviously started with this very rigid grid approach, very cubical. We tried to go into more round approach. We also went into very vegetative approach. We tried to get rid completely off of the grid. We also tried to use nuclei for setting up some sort of more organic feel, but we ended up going back to the grid approach and non-nucleus here because, first of all, nucleus makes you feel like some of the mushroom pieces has more significance than others, and that really interfered with the design. It was very clear that every piece has the same ability to regrow or to apply forces on nature. And also, it was very important to use the grid approach for two main reasons. First of all, you want to have some sort of a conformity to the environment. So it's almost predictable to see where this is going to, how this is going to grow. So it helps you when you try to move around or solve challenges, but also the grid approach gives the illusion of strength and the rigid skeleton that's very important to the gameplay. So the image on the left is where we were after just a few days of design. So this is more or less where we are now, and you can see that one of the most important parts in the mushroom is not just how it looks, but also how it grows and how it lives. So you can see that this is going to be a little more technical. So well, enjoy. This is a big mesh. This was single mesh that is made out of many vertices that interconnect with each other. Each one of them has a velocity, and the velocity kind of spreads around between all the vertices. So as the thing grows, the velocity of the growth of each vertex spreads around to all its neighbors. So it kind of gives it this springy approach as it grows, but then it sets. And when it sets, it stays put. That is the fungus feeling that we kind of wanted to get. So once it sets, it's rigid. But as it grows into the crevices. It feels very, very natural, hopefully. So, and the same technique is used for vertex colors. And you can see on the left when we use colors a lot on the mesh in order to, first of all, apply some gradient shading on the edges to give it a little more 3D look. And on top of that, you can see that one of the main things in the game is consuming creatures, absorbing their essence. You can see that by consuming that pickup on the left, the color spreads within the mesh in the same way that velocity does. Right, so let's talk about terrain a little bit.
So besides the design of the mushroom, one of the first things we had to figure out was our terrain. And it's a platformer, so we needed some kind of tile system to quickly make levels. This is our wish list, a modular design, so we could just take them and in the editor snap them cleanly into place very quickly. But still, they had to have a kind of a flow to it. We wanted many shapes, different sizes, angles, and it all had to fit together very seamlessly and try to avoid any obvious texture seams. And we wanted to reuse it because it took us a long time to develop this, and we are planning 7 levels or so, and it would just be too much work to redo this every time, and also it would decrease our memory footprint to be able to reuse this in some way. So we started with these angles. Basically, we have several different angles we want to explore at different sizes. So on the right, you see it's a 4x4 grid, and you have all these angles. And then we have a 2x2 grid for smaller curves, and then a single grid space tile that we can use. And up here on the left, we thought it would be nice to have kind of a shading on our tile that would describe that it was outside, and then kind of an inverted upside-down set with some different colorations that would describe if you were inside, like inside of a cavern or a tunnel. So these are all the kind of angles that we're working with. We have a straight line, concave, convex, or maybe it's the reverse, I can't remember. But we wanted to have that flexibility to have curves go in or out without having to think too much about it. This is what the tile set looks like. As you can see up top, we have the kind of light, pale shading. And down in this set down here, we've got like kind of a bluish tint, and that's to describe an interior. And then all sorts of irregular shapes. This one we use a lot. And a large texture square that we use to fill in large empty spaces. It's a seamless texture. Okay. And this is a close-up of the detail. It's a large sheet, and we wanted enough resolution so that the camera could get in fairly close, not this close, but we can zoom in and out without degradation. And whoops. Okay, so we've got these tile shapes, and I'll choose this one. Basically, this snaps. You have this little corner here, and inside is a very solid shape. But we use this feathered edge on all of these shapes so that while we're snapping it together on the grid, they all overlay. The feathered edge goes on top of the next tile and so forth, and no matter what texture is happening in the tile, it always blends very smoothly into the next tile. So that was very important for us, and it actually worked. And how do we go about it? We just start describing the shape of our terrain, different tiles. And then we take that large square tile I was talking about, and we can just sort of fill in the rest. And fairly quickly, we can prototype levels and puzzles and things like that. OK, so we have this tile set, but it's this gray material, and we really need more variety. We have all these things that are not just going to be in the background, which might be illustrated, but we need them to be play pieces as well. So right here, we have this just big block. It's supposed to be a building, but this is how we start. And we have a set of overlays, our terrain toolkit. And we just start placing them on, swapping out some of the tiles to refine the shapes. But in this way, we can quickly get a lot of variety and build anything we want. It's also a good way to vary the terrain. On the left here, it's a basic tile layout. But on the right, I've taken some of those overlays and just put them here and there, and kind of made it a more detailed place. And also describes some things, like maybe there's brick under cement poking through. Also, with this toolkit, we can make objects like these elevators were just made by dragging some bits and pieces and combining them. Same with this escalator. You make odd shapes that don't really look like anything in and of themselves, but they allow you the flexibility to use them in tandem to make anything you want. And speaking of all this detail, you have to be really careful about where you put it. This was one puzzle we have that is a favorite of ours. I wish I had video to describe it, but maybe you saw it in the video. But basically what it is this large stone arm, and you get in it, and it falls like that. And at a certain point, you have to let yourself go so that you can glide down safely to the ground underneath. And there is a lava pool under here, which you can't see. But what was happening was that people were seeing this ladder, and it's purely for detail in the background, but they would get confused by it, see it as a call to action. And then before we put the ladder in, everything was fine. Then we put the ladder in, and we realized that I was going a little too far with some of the details. So just a note, you really have to be careful about that kind of thing.
Right. So I want to talk a little bit about the animation style in Mushroom 11. So we already kind of started pushing it for the mushroom itself. But one thing that was very clear is that we wanted an organic, very fluid animation, animation that is based on the way it reacts to the environment or physics. It would move very, very fluently, and there shouldn't be any clashes like sprite keyframe animations. We tried those. Of course, we still have a little bit of that, but that really clashed and just felt wrong. It didn't work with the environment. So we tried to come up with our own solutions on how to make animations run well and work well with this environment. So this is an interesting example. One of the first things I tried, and also, as I always do, this stemmed from me being very lazy and not wanting to spend too much time in integrating art. So I basically took one art piece that Simon has made. In this case, we're talking about the pink creature on the left. And I just split it into many different quads. So it has a lot of detail and a lot of vertices that I can play with. And if you notice, the vertices themselves are completely stationary, but the UV positioning, which is each vertex position in the texture, that actually changes in this circular motion according to some sort of scheme here. You can see that at the top it moves a little faster, more horizontally. This is very, very efficient and has almost no performance footprint, but it gives a lot. It gave me a lot of opportunity to create motion in the world with almost no consequence. So this trick has been used extensively on grass and creatures and tentacles and whatnot. Coincidentally, you could see that in this image, you could see the only two other cases where we actually do use sprite animations, which is the mushroom itself with the background and the way it, the blood flows inside of it, and the wings of the sparkle fly thing. Just this is it kind of worked okay with the environment, but obviously when you try to make sudden changes between sprites, that just clashed really badly with the environment. But there's one thing that we use much more extensively in the game is what I call Vertex mapped bodies, which is, I also called it lazy man's soft body physics.
Laziness leads to innovation.
Oh, all the time. I think laziness really is my driving force in creating. Yeah, I mean, for me, if I get to a stage where I cannot delete any more lines of code, it means that the code is ready. So anyway, so in this case, again, one solution to try to get, for example, this blue creature here to move according to the environment or to physics was to just draw a lot of different sprites and try to figure out how to replace them at runtime. But what I try to do instead is to map actual physical objects to the vertices in the sprite. And so in this case, there are three main physical objects that are connected to the main object in spring joints. And obviously, they have colliders that attach to the ground and whatnot. Those are mapped into the sprite. And as the simulation begins, when they move, they start morphing the sprite vertices accordingly. And the result is looks very organic and exactly what I try to achieve. And that trick, which is the first thing I did with this technique, I started using it basically everywhere in the game. And you can see that the water is one of the things I really enjoyed making. It's actually one single huge semi-transparent sprite that is interconnected to a few quads horizontally. And on top of it, there's just a pretty basic chain of springs that allow the waves of the water surface to run across. And I map those, that chain, those objects on the surface to the water and just basically release it. And this is the result. And on top of that, you add some particles for splash. And I think it came out nicely. All right, so we'll talk a little bit about the creatures and the bosses.
So we have bosses in our game, and they've been a real challenge for us. They're like a mini game in and of themselves, and we often go into them with assumptions about how they're going to work, but it's never the case that it works the way you expect it to. So this is the porcudillo. This is Itay's sketch here, and this is kind of like a porcupine, armadillo, spike beast. And the idea is that it rolls around and it can really injure you. And we went ahead with the sketch and thought this is definitely going to work, and it's awesome. Let's just do it. And this is our first version. I think this was on display at IndieCade 2012. So the way this works is that you have this spike ball. It's kind of like this fleshy it's a flesh ball with armor on. And the way it works is that it shoots spikes at you and rolls over you, causes all sorts of injury. When it shoots a spike out, it leaves a soft, fleshy spot. So your job here is to, you have to make your way up here, and then poof, after it shoots a spike, you hit the fleshy spot. Yeah, you injure it. You do this 3 times, and boom, it falls apart. So it worked. This thing was going back and forth, chopping you into bits, and you could kill it. It was okay, but it didn't quite feel right. There wasn't a lot of consequence to it. If you think about the mushroom, you're roaming this landscape. You're eating things. You ingest them. It goes inside you. And this was sort of different in that we were just kind of touching something. You touch it 3 times. The magic number, and then it dies. So another thing is that we changed our design aesthetic slightly from a more technical, mechanical kind of look. We wanted to go more biological. So after a while, this didn't really fit anymore. So we went back to the drawing board, thought a little about the environment. Where does this thing do its thing? It's in an industrial level. So we wanted to put things like cranes, lava, smelting pits in it, things like that to accurately describe its domain. And then we thought, you really should be going inside this thing. You should be consuming things like you always do. So we decided, let's put some little, creature things inside this that you have to get in there. And then it makes a little more sense. So I did this version based on our ideas. Still, you're shooting your spikes out here and leaving a very tiny gap. You've got some biological entity thing going on here. It kind of looks like eggs or cells or something. The problem is that it's a bit alien looking. It doesn't look like it belongs in a factory or some kind of industrial level. It looks like nothing else in the game. And these little cells don't really speak of any kind of intelligence or action. So I thought, let's keep on going. And this is where we ended up. This is how it is in our game. It's a very mechanical apparition now. Our little cell creatures have been replaced by these bright slugs, and we made it more obvious that you just need to get inside this thing and consume things as you do. And then you can destroy it. Another challenge, this is the boss on the first level. Again, we sketch, come up with a concept. In this case, the idea is that this creature, you have to open up. You got to get these things, right? You've got to go in there and eat all those glowing bulbs to kill this. And when it snaps shut, it flings you over in the air, and you might land in the lava, or you just can't get in there. So it's a timing challenge, ultimately. And for level 1, we realized that this really isn't what we want to do here, because on level 1, we want to basically be teaching the player about this new mechanic that they may not have encountered before. So we want players to continually learn about climbing and balance and how to manipulate your mushroom in the game. And this just wasn't cutting it. So we redesigned, thought about limbs that are flailing about. It's going wild. You still have to get the glowing bulbs to kill it, but now you've got to do things like you got to climb over here. You've got to somehow get over there. You've got to get all these things, and it really challenges your navigation ability, which is what we wanted. At the end of the level, you're learning all these things. This is what we wanted to finish with. We also thought about here, how do you exit? Why are you even killing this thing? It's a living thing. Well, you've got to kill it because you have to get out of there. So we started incorporating a reason like this, like an exit strategy into our bosses. And we feel pretty good about this one. It worked out pretty well. So there's a certain ambience mood we want to have in our game. And one of the important things is the visual depth in the game. There are many ways to achieve this. Obviously, there's the playing with the values, dark, high contrast, closer to you, and then they get pale as they go into the distance, less detail, that kind of thing. But also, we used the Z-depth extensively. Itay set up a very unique camera situation so that we could have real perspective as well as have our playability. But it's very important that we keep the separation from the playing field where you need to navigate over the terrain or you need to interact with things. We need that to be separate from this background. And as the background gets richer to describe this world, you sort of run into this danger of making it too rich. So we need ways to separate the foreground and the background. One of the ways we overcame this was going back to the tiles. We have a little highlight on the edge of it that provides some contrast that you don't see in the other background elements. So we have that to kind of bring the terrain forward, as well as we can tint anything in this game. It's sort of like lighting. Tint it different colors to push it back. So in this case, we have the wall. It's kind of a reddish color, which pushes it back. It separates them and makes everything much clearer. So speaking of lighting, I wanted to have a way to describe how light hits some of the background objects, like a wall, as it's on the outside. But then when we're inside, we want to have darkness or different lighting effects, spooky glows, that kind of thing, like this it's an acid pit. I don't know if you knew that, but acid pit, or the light coming in here, you could see how it shades the wall there, and it's dark here. So we need to have some kind of system of controlling that, and we thought about making a bunch of tiles for this wall, for instance, that would go from light to dark in different angles, but that's a lot of work. And imagine if you had to do that over 7 levels. You would just spend all your time trying to achieve this one effect. So we needed a better way, and Itay will talk about this in depth.
All right, so in order to kind of take the artistic vision and put it in the game, put it into reality, we had to create the environment that would work and be able to fulfill all these bullets in the wish list, but also in a way that would make everything not too performance heavy. So, and also obviously work well with each other. So, talking about the layout and the structure of how the game actually works. So, one thing that is pretty obvious is that the game runs in an orthogonal camera, meaning that there's no perspective. And as things go farther into the background within that camera, they would not change the size. That would enable you to play with the Z of many sprites and objects without worrying about sprite gaps and other problems that could arise. So it's pretty obvious that everything related to the gameplay itself runs in the main orthogonal camera. But we also wanted to have this rich environment, so we created an additional background camera that is perspective. And they all work together, they move together, and even when it zooms in and out, or changes the field of view, whatever, they do it simultaneously, or at least in a way that's as close as we can get it to work. So that enables us to, instead of try to fake parallax, we actually build objects in the background, and as the camera moves, those move respectively. And we can place background objects anywhere we want in the background, and it would just work well. Same thing we wanted to do on the other side of the camera, which is the foreground camera. Is also perspective. We can have as many layers of foreground as we want to kind of give it more holistic, rich look. So there are 3 cameras, and on top of that, there's the GUI camera that is used when we need to display menus and stuff. So, and this is how this image would look aggregate. If we talk about the depth, you know, I was talking about the different layers of background. Usually what we have is basic 4 layers of background. You have the sky, another 4 layers of cycling backgrounds, and then we add some more one-offs, like buildings and other structures to kind of break the monotony. So Simon started talking about the lighting, and lighting actually was very, very important because we were struggling with how to make the game look very rich, and I feel like this is a theme that returns a lot in this talk, and how to do this without too much work. So I came up with an idea which I called the tint orb, which is basically a set of lighting interconnected light orbs or tint orbs that are laid out across the scene. That each one of them has a certain value and a certain color that you would apply according to the theme or the area that you would want to shed the light or darkness, for that matter. And so what you would do is you start with the very basic, I don't know, in this case, the cave. And the background tiles are all homogeneous, pretty light, very basic color that you can later use to tint darker or lighter. So this is how you lay out the scene. Now you try to figure out how exactly you want the scene to look like. In this case, we wanted to, I don't know if you see this, but there are some darker tint orbs at the top of the cave. Then you have a lighter orb in the entrance, and another orange orb by the lava pit. And what they would do, the way it works, those actually interact with the specific vertices of all the sprites in the scene. So once the scene starts, it will all those sprites try to figure out where are all the orbs around it, and they will get all the color values from those tints according to the distance from the center of those orbs. And they would tint themselves. And the good thing is that this is literally baking the light or the color into the sprite, which means that it has 0 performance footprint. There are no point lights or any such thing. And the result would be like this. Right. So a couple of more tech-heavy tips as we approach the end of the talk. So Overdraw, I think every programmer or technical artist probably know this term. Overdraw is, very generally speaking, is the number of redraws you do per pixel on your display buffer. And obviously, you want this number to be as low as possible, because if you don't have any pixel drawn on a certain position on the screen, that's of course ideal. But the more semi-transparent colors on a certain pixel you have, the more passes you'll have to do on that specific pixel, which takes more time to the GPU and whatnot. So what you wanted to do is, first of all, reduce your draw area. And probably noticed that we use the quad splitting on the sprite extensively for a lot of things, for animation and obviously for lighting as well. But once you split your sprite into quads, you can actually remove some of the quads that are unused. In this case, you can see that some of them are completely absent. It's a very easy approach for us to just trim the edges off in this case, the top of the background elements. But on top of that, we try to use opaque materials as much as possible, because once you have an opaque pixel on the screen, there's nothing that's going to be drawn behind it. That's the last pixel to ever be drawn in the buffer. So in this case, we use these are two examples of sprites that are split into two parts, the opaque part and the semi-transparent part. We always try to kind of extend the size of the opaque part as much as possible, because that is much more effective and efficient. All right, and everybody knows about draw calls, but again, a draw call is, very generally speaking, is one pass in a single render queue for a single mesh with a single material on a single light, I think, something like that. Anyway, so the more objects, the more meshes, the more materials you have, the more draw calls you'll end up having. And we wanted a very, very rich environment. Obviously, we tried and succeeded pretty good to reduce the overdraw, but we also wanted to reduce the draw calls. And the great thing that Unity does is it batches draw calls in the way that for a single render queue, it tries to batch all the meshes that use the same material and then batch them together into this mega mesh and just send it to the screen. But as soon as it hits on a certain render queue, as soon as it hits a material that's not from the batched material, it just moves on and just displays whatever it already got. So what we would want is to help Unity figure out the render queues, kind of like sort it or pre-sort it before it gets to the GPU. In this case, you can see that this is a pretty heavy scene. It's actually from the game. It has a few creatures. It has a mushroom, which already has two materials in it, and you have lava and many, many layers of background, and it has 10 draw calls. All right, and the way I'm doing this is by extensively using the render queues. In this case, you would see it in the transparent +3 there. That's a render queue. It means that it will be drawn 3 layers after transparent, which is the basic order of where transparent materials are drawn. So if I know that a certain material or a certain set of materials will be drawn behind others, I can help Unity to pre-sort it by telling it that this material or this set of pieces would always use that pass. And on top of that, obviously, we use very, very large sprite sheets for anything that can be combined together. So all the creatures use the same sprite sheet. All the background pieces for a certain level would use the same sprite sheet. You could see that the sky and the background strips, as well as the background elements, they all share the same sprite sheet. Quickly talking about the story here. So the philosophy here is that what we wanted is to have a story that is presented in all the elements around you. We didn't want to push the story onto the player in any way. No cutscenes, no comic strips. But if you look around, if you care to look, then it's there, and we would not push it in any way. And so you can see the details are all around you. You could see it and they interact with the story, but in a way that we cannot really. You only support it through different imagery. So it's very, very important for us to just place a lot of elements that come from the story that we came up with, but not pushing it in any way that will have you stop and read or anything. And on top of that, we were able to get some support of additional imagery that gives you a little more information and kind of speaks the same dystopian world language that we want to present here, give you some idea of what happened there. But also, even that is given to you in a very context-free manner. So that those interact with the elements you see around you, all the items on the scene, and they also are presented in a way that doesn't give you any information about the chronological order. So in a sense, you create your own context and your own version of what really happened there. And personally, we are very, very happy if people come up with their own version that is not the story that we came up with. So yeah, we're still working on the game. We still have a few more months of work. We're planning on releasing it early 2015. Hope you check us out. We're going to be next week in presenting PAX 10. So thank you very much.
Thank you.
Any questions? If you have any questions. Yes?
So, you described several instances of kind of coming up with interesting techniques to help out with your performance or to kind of get more value without doing so much visual work. Were any of those techniques anything that you had to kind of fight Unity a little bit for, or any of them particularly painful to implement?
So I'll repeat the question. Did I have to fight Unity for some of the techniques that were there to support the visuals? Yes, in probably every single one, and not because Unity is bad or anything. I'm so thankful for having this tool at my disposal. It's pretty amazing, but it has its limitation. What I talked about with regard to the draw calls is a great example. It's an amazing tool. Batching is such a smart tool, but if you're trying to make the batching smarter, of course you can do that because you could sort it. You can have Unity sort it for you in a better way, but that would make Unity work so hard that all the time that you save on the GPU you actually waste by trying to sort it. So we're just helping it. It's a very easy tool for us to just tell Unity, you know what, this is a different layer. Just don't worry about it. Well, there are many other examples, but it's not even limitations. It's just, this is how it works. So let's just trick it and push it into the right direction. Any more questions?
Okay.
Okay. Thank you for coming.
Thank you.